Oh, here we go. So I'm going to talk today about challenges and opportunities of ops in a large cross-functional organization. This mic is a little bit fuzzy. Okay. No, that's good. Okay, yeah. Okay, so I like to start with this diagram because it's pretty intense, but it's also pretty accurate, right? So I'm trying to set the table so we can have a common understanding of what is MLOps, which I think most of you in the audience probably do know, so then we can talk more specifically about some of the challenges you might face if you're in a really large organization. And this is from a recently published paper, I think it was earlier this year, called Machine Learning Operations Overview, Definition, and Architecture. I highly recommend it. But one of the things I like about this is it calls out really well many of the different things we need for success with MLOps, a feature engineering pipeline, experimentation as part of the model development process, automated ML workflows and pipelines. I would definitely recommend checking out this paper. But what I really want to do is anchor us in a specific example, because I think this is something that we're all pretty familiar with. We usually pay for things with credit cards, right? And I think this is a really good illustration, machine learning transaction fraud model that sort of helps us frame MLOps. So we're all familiar. We go to the grocery store. We go, someplace. We put our card into the reader. We swipe it. We tap it. We wait a few seconds, and we get usually an approval. I think sometimes a decline, but usually approval, and we go about our business. So these types of models are not unique to Capital One, right? These are, any sort of large financial organization, credit card company would have something like this. But behind the scenes, in that 2 seconds that you're waiting to pay for your groceries, there is a ton of stuff happening, right? You have to pass some data someplace, often to the cloud, not necessarily. That data, you might need to calculate some features, need to be passed into one or more machine learning models. Then you might have a decisioning logic layer, and then finally you're going to get that approved decline decision. And so all of these things happening in all of the systems under the hood and all of the pieces and the people that come together to make this happen, that's MLOps in a nutshell. And so I really love this example because I think it's something we can all relate to, and I think it definitely helps me frame in my head how to think about MLOps. So next slide. Okay. So what are some elements that we need for this to be successful? Well, one, you need the model to predict approved decline decisions. You need data that securely flows real time into this model so predictions can be made. Data security, I'm guessing some of you in the audience might be in the healthcare field or in financial services like we are. Data security is critically important. It's regulated. And so you need to make sure that any data that's flowing any place is happening really securely. You need a system that can handle thousands of these transactions happening simultaneously. And then you need to make sure that there's almost no time, right? So all of these things are really critical components of MLOps. I also put this diagram up here because this is from one of my favorite papers, Hidden Technical Debt in Machine Learning Systems. It was a MLOps paper in 2015. And the thing I love about it is that little black box in the center, which says ML code. Used to live for a long time. I come at this from the perspective of a scientist, of a data scientist, but it's really true that that little bit of code is such a small fraction of all of the things you need in order to do MLOps successfully. And so I really love this diagram, and I love this paper. So one more thing before we get into the meat of it. One thing I like to call out when thinking about and talking about MLOps is that there's a difference between building a model versus serving it. So when you're building a machine learning model, it's a scientific process, it's iterative, it's exploratory, right? You need to make sure that you understand what's in your data. You need to understand the statistical distribution of your features. You need to make sure that the model is predicting what you think it should be predicting and doing it to a sufficient level of accuracy. And all of these things take time, and you do it through an iterative process. Well, when the time comes to serve that model, you have a totally different set of questions, right? Do you need to do this batch, or do you need to do it real time? And what's the infrastructure you need for that? You need millisecond response times. You need complex orchestration. And so these are really complementary skill sets, but they're both needed for the MLOps. And so that's why I have this little, let me scroll up a bit. Yeah, that's why I have the little, the little bit in the middle right there is what you need for success. Okay, so now let's imagine we're in a large cross-functional organization, and what are some specific challenges that we're going to have with MLOps? And this is actually really interesting for me personally, because prior to being at Capital One, I was at a startup, and in that startup, things were very, very different from how they are. So it's been interesting for me to experience both sides of this coin. Okay, So one of the first things is you're going to have some challenges with org structure. So when you're in a really small company, you might have your data scientist and your software engineer and your DevOps person and your product person all in a little pod working together. Communication's really easy. When you're in a large organization, there's a lot of different ways to structure it. But one way is you might have product over here and tech over here and data science over here. You might have a specific organization responsible for risk. Product is, the lines of business are over here. And so there's sometimes some inherent tension among the goals of these different organizations. So we just heard a talk about risk and governance, which is critically important, and I'm going to talk more about that in a bit. But if you're in the risk organization, your job is to minimize risk. If you're in the product organization, your job is to build awesome products. And so you need to communicate clearly to these two things come together as they need to. And then another thing I want to call out is the tension between model development and surveying, which I talked about on the last slide. That is exacerbated in a large organization. So I am guilty of this. I like to say this a lot. Data scientists are special snowflakes, and they like to say, I need to build it this way, and I can't possibly use anything else that anyone else has ever built. Well, then you get a lot of really bespoke things, and you get a lot of really bespoke artifacts and metadata, and it's hard to do CI/CD on everything when it's really bespoke. So there are some ways to combat this through standards, consistent artifacts, a unified stack. But this is an organizational challenge, and we can partially meet it with technology, but we also need to meet it with communication as well. And one thing I want to call out specifically is that when you have technical contracts, really specific technical contracts between all of these different elements of your system that you need for success with MLOps, that's going to help you. I'm not saying don't communicate, that's critically important, but if you think about something like and protocol buffers, right, which are designed to make coordination easier across these massively distributed systems, that helps enable, these different connection points, so you don't necessarily need to rely on the communication. I think we all know organizations change, people leave, new people come in, there's reorgs, and so having the ability to be a bit resilient to that because of the technical decisions you've made, I think is important. Okay, so what's next? Okay, so the next thing I want to talk about is that large distributed systems have unique security challenges. So I'm going to frame this example as when you think about all of the things needed for MLOps, one of the things you need is a platform of sorts so your data scientists can train their models. And the larger your organization, the more likely you are that you're going to have a lot of people hitting this system. And so you need to think about security in a different way. So if you have a really small number of people using whatever you built, you might not even need Kubernetes namespaces, right? This is a diagram I pulled off of Google's website. But once you get larger and larger, you need to have namespaces, and you have different tenants using your system, and you cannot have tenant 4 accessing the namespace of tenants 1, 2, or 3. What happens if they can leverage a disproportionate amount of compute resources? I've already touched upon data security and data privacy. That's really important. And now let's imagine that there are M tenants instead of 4, right? Is N 10? Is it 20? Is it 50? Is it 200? So it's hard for us as humans to think about all of the different interaction points in a large system like this. But we need to think about it a little bit differently than if you just have a platform where you maybe have 1 or 2 data scientists on it trying to train their models. Okay. And one thing I know that I certainly think about when architecting systems or thinking about products or thinking of solutions is that I always say the business problem is really critically important. It needs to come first, and you need to have your functional requirements. And I think that's definitely true, but certainly in large organizations, when you're building large distributed systems, you need to put these security constraints at the same level as your functional requirements. So number 1, if you think about it, multiple entry points to your system are going to increase risk. Users are going to bring things to your platform that you do not anticipate. Data scientists are good at this. And so that's something you also need to consider against. Privacy, taking a configurable, nuance, and identity-based approach to access control can help you there. Cluster management, right? You need to make sure that you cannot give one tenant on your system access to all of your compute resources, and then you leave none for the rest. So that's another thing that you need to consider. And then finally, a seamless user experience. So that doesn't just mean minimize the risk of system downtime. It also means the creation and curation of an experience where data scientists don't have to focus on cluster management and security, right? If I'm coming and I want to do the practice of data science on this platform, I know it needs to be secure. I know that all of these things need to happen, but I don't want to have to think about them too much, right? So your user experience is not just for your end users, where this model is going to be, consumed in whatever product it's being consumed, example, transaction fraud, but you don't want your data scientists to have to focus on this either as they're using the platform. Okay, so I want to talk a little bit, I'm going to close those. I'm going to talk a little bit about monitoring and how really proactive, intentional monitoring can mitigate operational risk. And we just, the previous speaker touched on this a little bit when he was talking about governance. But at the end of the day, when we're talking about MLOps, we're talking about machine learning, is we are using machine learning to make a business decision, and that's going to impact somebody, and there's risk associated with that, and you want to minimize that risk. And this is also an opportunity for me to cite one of my favorite quotes from the statistician, George E.P. Box. All models are wrong, but some models are useful. And your models are going to get more and more wrong and less useful over time. You don't want to get to the point in your transaction fraud model where it's approving fraudulent transactions or you're declining good transactions with some regularity, right? And that means you need to retrain your model. And in order to know when you need to retrain your model, you need to monitor what is happening when you use it. So there's another aspect to this as well. So one is monitoring what happens so you can look at how the performance degrades and know when to retrain, which if you've built everything really resiliently, then you can often have automated model retraining as part of this whole MLOps process and ecosystem. But the other thing I want to call out a little bit is that coming back to model development being an experimental process, and you're iterating a lot. And one thing that's critically important to reduce risk is making sure that you can reproduce everything you're doing, right? Like I've been guilty of this. You're in your Jupyter notebook and you're training a model and you're like, aha, I got it. But then you did a bad job maybe tracking your experiments or keeping good track of your hyperparameters or all of these different things. And the reason you want to do this is because having that reproducibility can reduce risk. At Capital One, because we are a highly regulated financial services organization, all of our machine learning models go through some place called the Model Risk Office to make sure that we're doing everything, safely and with minimal risk to our customers. And part of what they ask for is a justification. Why did you choose this model? Why did you choose these features and these hyperparameters? And so tracking it and making sure you have clear reasons for why you're using the model that you are is also going to help you with that monitoring as well. So you know what to look for and you have a better sense of your performance degradation. So this is something that I think is tricky to get right, but I think it's so important. I also want to give a little plug for some of the great work done by my team. We've actually open sourced a package a couple of years ago called Rubicon, which helps with some of that experiment tracking. And if you come to the Capital One booth later, I would be happy to talk your ear off about it. Okay. I want to call out, I want to talk a little bit about build versus buy. So I've been talking a lot, I showed that little Kubernetes diagram and I was talking about a platform where your data scientists can go to train models. And I've been talking about it as though of course you would just build this, but actually you might not want to build it. And the thing that I want to call out here, it's not yes, you should build versus yes, you should buy, but the calculus for this is different in large organizations versus small ones. So for example, if you're in a really small startup, you're trying to solve, whatever problem you are to become the next unicorn, and you probably don't have the engineering resources to build out a machine learning or some type of modeling platform. If you're in a large organization, you might have the tech resources to do this, but you still might not want to. You need to make sure they have the right skill sets. And for all of the software engineers in the audience, you know that anytime you write one line of code, that's one more line of code that you have to maintain. And maybe systems for a specific period of time is costly. And so as you're thinking about these things, do you really need this for your business use case? Do your tech teams, not only do you have the size and the budget, but do they have the skills, right? We think about open source a lot. I love open source. I'm a huge fan. But just because something is open source doesn't mean it will work for you out of the box. And you're going to need some teams to help put things together in a way that's going to work for your organization, and this is particularly challenging in the machine learning space. So some lessons learned. So I've sort of talked about a lot of different challenges that pop up in large organizations, but the flip side is that you can be successful with this, right? You just need to be really thoughtful about everything, how you design things, how you execute things. And as you think about building out the infrastructure you need for MLOps, take the perspective of somebody who doesn't know anything about MLOps whatsoever and is going to try to use your system, and the perspective of someone who's probably actively trying to break it, right? And how can you factor that into your architecting and your decision-making process? I want to call out a few things that we've been working on at Capital One. One is really a focus on, SDK standards, a unified stack, incentivizing reuse, right, to try to get rid of a lot of the bespoke uniqueness that I think just naturally comes up in this field, and so really, really standardizing to give us the ability to scale the way we need to, prioritizing a clear set of use cases and stakeholders, and building for those folks first. You can't be all things to all people. I think we all know this, and so prioritizing a really clear use cases and stakeholders is going to help you out. And then really having a focus on monitoring and logging. I know some of my colleagues here, if you come to the Capital One booth, can talk to you about, the unified stack, about some of the things we are monitoring and logging, but really taking some of these requirements that can be challenging, right? Like going through validation with our model risk office is not an easy process, but it's so valuable. And so taking these requirements and really flipping them on their head and making them something that you can take pride in, and it makes you better and more scalable. I think the final thing that I will leave you with is being in a large organization like Capital One is you have the ability to see the work you're doing help solve really impactful, critical business problems, right? You think about virtual card numbers to help protect you, from fraud, CreditWise, which allows people to help, have more information and really, take charge of their financial future. And then the Capital One Auto Navigator, which I don't know if there are any Schitt's Creek fans in the audience, but the commercial with Eugene and Sarah Levy, where he comes to help her, and she's like, I don't need help, I use Capital One Auto Navigator. All of these things have machine learning in them, and so the ability to work on problems of this scale, I think, is really exciting. So even though you might get some additional challenges in a large organization, you also have opportunity to solve awesome problems as well. So that's it. I think we might have time for a couple of questions, but also I want to shout out that we have a booth. I will be going there actually right after this talk, and I know many of my colleagues will be there the rest of today and tomorrow. So if you have any questions about any of this, please stop by. And I want to thank you all for your attention today. Any questions?
We have time for about one question.
Ooh.
Yeah.
The picture, I think it's of our office in McLean, Virginia. So yeah, but yeah, it's not Richmond, not the Richmond campus. We do. I'm not sure how much I'm allowed to disclose about specific models. We definitely have, we do work in anomaly detection, risk, etc. But I can't. No, I can't get into too much detail. Yeah. Sorry, can you repeat that? I didn't hear.
Can you talk a little bit about testing resiliency models?
when you say resiliency, you mean like how well the model is predicting? I mean, I think that this is part of where our partnership comes in with the model risk office. Is part of like they provide usually a lot of specific feedback, sometimes even retraining models. So you get like, it's almost like an internal champion challenger to make sure that we're really like pushing things before we put them into production. There's also a lot of work going on, just explainability. We make sure we test like most of the models with different explainability techniques as well. So that's a sort of incomplete answer, but same as for him, I have to be a little bit vague. So